Since you're closest, can you get the lights for me? And then we'll just start like right now. Let me pass back any tests. So remember, you guys have to do test corrections by the end of the month. Turn this back in. So I only have really Mateo. Has anybody seen Ethan at all or not?
He's here earlier. I saw him. I don't know.
Okay, all right. But Mateo, I have your test corrections. Or your tests. So again, if you guys don't know how to do test corrections, extra sheet of paper to go with this. Write all your questions that you got wrong, and then give me the right answer, and give me one sentence on where you went wrong. Okay, thank you very much. Yeah, with like a different color pen, but yes, that's absolutely right. Okay, let's look at this over here. Ava, your test is over there on the desk. It's month 1 math, right? Advanced math. Okay. All right, so let's start notes right away. It's going to be 3-4 transformations of quadratic graphs. Last week, I spent I wasted 5 or 10 minutes just trying to get the right section, like the naming. So this week, I'm a lot more prepared. Well, hopefully, let's see. Okay. And let's do first not a real warm-up, but let's look at this equation. So let's just you don't have to write this one down, okay? But let's look at this. Y is equal to x squared minus 4x plus 6. My first question to you is, what graph are we going to expect? Like, what kind of curve? Is it like a line? Is it a curve? Is it like parabolic? Or what were you going to say? Yeah, go ahead and motion it. Yeah, it's like a U shape, right? Okay, so first off, how could you tell? Like, what gave it away right away? What?
The format. Quadratic.
The quadratic, the x squared. Perfect. Okay, so I want you to recognize that. And I want you to... and one more thing. If it's a parabolic shape, does it open up or down?
This one goes up because it's not a negative x squared.
Okay, so we have to look at the number in front, or like the value in front of the x squared. If it's not, or if it's positive, it just opens up like it normally should. If there's a negative sign in the front of here, it automatically points the whole thing down. Okay, let's take a look at this really quick. Yeah, go ahead. Go ahead. Yeah. This is just more conceptual anyway. So you can always kind of go back on the video if you want to see what we missed. Now, do you guys prefer me to do graphing on Desmos or the actual TI-83 calculator? So you guys get used to me doing like what you guys would have to do at home. Any preferences? No? Okay. I'm gonna do it on Desmos just because I think it's a little faster when I'm trying to go over stuff, as much stuff as I can with you guys in class, and like the very little time that we have together, you know. Okay, it's x squared, plus 4x plus 6. Okay, so we're gonna take a look at. Dang it, we're gonna have to take a look at that. Plus 4x plus 6. Someone remember that for me? Thank you. Yeah. Okay. All right. Can you kind of give me a guesstimate for the vertex for this graph? When I ask for the vertex. First off, what is the vertex in this case? Like, to describe it, what is the vertex when I ask for the vertex of this parabolic graph? And I think you're right. Yeah, it's negative 2, 2. That's about the vertex right there. But how would you describe what the vertex is on a parabola? Yeah, Catriella.
The lowest or the highest point on the parabola, depending on whether the curve is whether it's directed downwards or upwards.
Exactly. So it's either the lowest or highest. In this case, why do I not say that I can find the highest point on this parabolic graph? Yeah, it just goes. Yeah. If I keep. There's no single point. There's no singular maximum point, but there is a singular minimum point. Now, can we be sure that that is the lowest point using the tool that I have? Well, how could you say yes?
Because when you're tracing it, you can see if there's any values that are lower than that, even if it's like a decimal.
That's true. I mean, my only thing is it's purely tracing, and yeah, you can see the programmers when you point it most down, I guess, pretty well. It'll estimate the vertex really well. But mathematically, we want to be absolutely 100%. So there's another way that we do that. We use a calculation to make sure what the vertex is. We say it's about negative 2, 2, right? But if you recall what the formula is, does anybody recall how to calculate at least and when I ask for the vertex, it's a point, it's something, comma, something, right? It's an X value and a Y value. Yeah? Malia, did you want to, I thought you had your hand up or something like that. No? All right. Do you recall how to calculate at least the X coordinate for the vertex? It has something to do with B's and A's and C's. It has something to do with that. It's pretty tough to recall, huh? You can't just recall on the top of your head, right? The quadratic formula is to find the x-intercepts. So, but you see how easily mixed up it is? Technically, what you're supposed to do is you're supposed to do this. You're supposed to plug in negative b over 2a, okay? And then you calculate that, and then you get the x-coordinate, right? And then afterwards, whatever that x value is, you got to plug back into the equation and then get out the y value. Would you say that's a really easily intuitive, memorable way to do that? It's not really that nice. But another way we can write this equation is in this way here. I believe it will. So this is gonna be exactly the same thing. It looks a little bit different, but these two are exactly the same. Take a look at that and tell me, can you see the vertex in this equation? I'm going to go back to the point, or I'm going to go back to the graph really quick. That's our estimated vertex, negative 2, 2. Where can you see the vertex in here? Can you see the vertex in there? I'm going to do another one. Again, don't write this, okay? 4. Let's graph this guy. X plus, all right, so Ms. Gould, help me out here. Remember that equation, okay? X plus 3. What was the last part? Okay, thank you. Okay, I'm gonna point to the vertex right there. Where do you guys see the vertex in these two graphs, or these two equations? Can you see the coordinate for the vertex? Where do you see it? Did you? Can you help us out, or?
The y is in the latter part of the problem.
Yes.
And the x is inside the parentheses with the opposite sign.
There you go, right? Wouldn't you say this is way easier to see the vertex than it is to do up here, to see it in this way up here? You see how if you have it written like this, I have to go through this whole calculation with negative b over 2a, and then I got to plug it back into the y, right? If you write it this way, you can just see the vertex right away, okay? So let's go ahead and take some notes. Today, what we're going to do is we're going to learn how to transform this into this, okay? So that way you have 3 ways to find the vertex. It's really important. It doesn't seem like a big deal, but let's say if you're a financier or you're a person in an accountant and you have to look at, like, I think I like using that analogy the most because you see how companies and their patterns in money flow. And a lot of times, if you can nail that the pattern is going down and up, then you can use just basic math that you've learned before to see, you can estimate how low will the money go, okay? If you can, okay, I'm getting a little ahead of myself, but you need to know these skills if you want to be like a high-level financier, okay? So we got to learn how to go from here to here, right? So now let's begin some notes. So we're going to learn how to write in vertex form. We're going to learn how to write in vertex form. And I'm going to say originally, what we call quadratic equations. Quadratic equations, not the formula. The quadratic formula is to find out the x-intercepts, okay? But a quadratic equation would look just like this here. That's a quadratic equation. Originally, our quadratic equations were written in standard form. In standard form. Let's have a comparison. So originally, this was standard form. Ax squared plus bx plus c. That is standard form. Vertex form is going to look like this. So today, we're going to learn about vertex form and how to make a standard form equation into an equation that is in vertex form, okay? That would be a times x plus or minus h. I'm sorry. The standard way to write this is minus h squared plus k. And I'm going to say such that the coordinate h comma k is the coordinate, okay? The coordinate of the vertex. So this is the new one. But this is what we've always seen our quadratic equations written as. Today we're going to go from here to here. There's a lot of benefits to doing it from here to here, right? Any questions so far before we kind of move on or no? All right. So let's give you an example of what that would look like. The directive is to rewrite each function. Okay, a way of understanding a function is it's an equation. Each function in vertex form. So I will give you this. Y is equal to x squared plus 4x plus 6. We need to rewrite that in vertex form. I'm going to show you how to do that. The math that is required to do this. The math that may not be understandable in the textbook on your own. To do this, we're going to do something that's called completing the square, okay? Does anybody recall what that kind of looks like? Like, what is completing the square? Does anybody recall at all what that's going to look like? Not quite. It's kind of weird. Okay. I will help you with this, right? You know what? Instead of just showing you guys and just telling you to memorize it, let me see if I could just Google search it, and then you guys can just tell me like what you guys see. Completing the square. So that way you guys aren't purely listening to me. Maybe you guys can actually help me out here. Where's a good example here? Where's completing the square? Okay, here. All right. I'll just zoom in here. Okay, this is a good example of completing the square. What the heck? I'm so old. Okay. What's happening here? So this is the way the equation originally was, and then you change the way it looks right about here. This is completing the square. What happened? What things happened here? From here to this step here. What did we do?
They separated the x squared minus 9x from the plus 12. So they took the x values and they separated them from the variable list.
Yeah, so the variable list, or the variables, right, plural, they're over here. We kind of put them in parentheses, and we kind of took out that number. That's called a constant, where it doesn't have a variable, okay? What about this next step? The 12 is right there, okay? But what did we seem to do in this next step here?
Because they did it as if they put it as x minus 3, I think, and then squared it and then took the values that would come out of it extra and tried to subtract them out so that you wouldn't see those.
Kind of follow along with what you're saying. That was a little tricky.
So they tried to make it to where they could square the two x values.
The two x.
Yeah.
Oh, I see what you're saying.
So
okay.
when they did that, then there would be excess that wouldn't come out to x minus 9x, like the x squared minus 9x. So they had to get that out of the way too. So that's why there's things that are being subtracted there.
Okay, so I see what you're saying. I don't think everyone else can quite, because I can get from kind of their perspective, like, I'm not really getting that as fast.
From doing the work.
So that's probably okay. Okay, that's cool of you to say that, to tell us, like, yeah, I just got it from the work. You guys notice that they took this value here in front of the x, and what do they do in this step here? What do they do with that value here? They divided by 2, okay? And then they squared it, right? And then they added it here and they subtracted it here, right? Let's see if you can identify that happening in here. Did they do the same thing in here? From this step to this step? Did they divide this by 2?
No, yes. Yeah.
Wait, why do you say yes?
Because if they divided by 2, it would be -9.
Uh-huh.
And then if we square it, it would be 81, and they added 81 to both sides.
Do you see that now? Okay, so this one's a little bit different because you added 81 twice, but that's because there's an equal sign there, and you have to add 81 to both sides to make this side equal to this side, okay? And this one over here, the previous example, okay, when we added that here, everything was on the same equal sign side. You see that on the right side of the equal sign? So you're adding it, and then you're subtracting it here. Let me give you another example. They're not really that good. So this one, did they do the same thing here? Did they take this, cut in half, 12 divided by 2, and then did they square it after that?
Yeah.
Yeah, because that would be 6 and then plus 36. What about from here to here? What happened from this step to this step, though? So this is what Catriella was saying. There's a reason why we did it like this, why we had to take this, cut it in half, and square it. This goes to here. What the heck happened? How could we do that? Why does that work? No guesses, or yeah? I just want to give it a shot. Wow. Okay, that's really good. You even got the words down right too, the vocabulary, okay, and how to describe this. Yeah, this is actually a perfect square trinomial. What I mean is this. Can you take the square roots of both sides? Can you take the square root of x squared?
Mm-hmm.
Yeah. Can you take the square root of 36? In the middle, the rule was it had to be 2 times each of those roots. It had to be 2 times x times 6. Do that in your head. 2 times 6 is 12 times x. That's a perfect square trinomial. So what that will look like when you factor it back down to 2 binomials is x plus 6 times x plus 6. That's a perfect square trinomial. That's what we call completing the square. It's a lot of things that you just did, but let me just show you the process now. So you guys got a lot of jumbled information in your brain. You're trying to piece it together, okay? So hopefully when I show it to you, some things can kind of fit a little bit better now, okay? So I just want to give you a reason for what you're doing, at least, or like kind of get your brain actively engaged so you're not just like, okay. Even though we might just be, okay, all right? Okay, so here's the first step in what you're going to do. So they bunched those together, okay? They bunched the variables together and they left out the constant, right? That's the first step. And they're going to show it to you just like this in the book. And then the second step is you probably want to make a space. So you're going to plus 4x, you're going to make a space to add in the variables, like in that parentheses with the variables. And then on the outside, you're going to subtract, and you're going to have a space too, a blank space as well, okay? What was the next step? What goes into this space and this space over here? There you go, all right? So the general formula for that, technically, this is b. b, you divide your b divided by 2, and then you square it. In this case, our b is 4, so we divide it by 2, and then you square it. What is 4 divided by 2? Yeah, and then 2 squared. So it's almost like you really didn't have to go through all that much work, but you did, okay? So you add 4, and you subtract 4. Any guesses as to why I'm adding and subtracting it? What is the reason for doing that? You can find the vertex form, or yeah, like you said, okay. Any other reason why? Any guesses as to why it is? I told you that this is standard form, right? And we're rewriting it to vertex form, okay? So we're going to change the way it looks. But did I say we changed the value?
No, you don't change the value.
If I only added plus 4 here, wouldn't you say I wouldn't? Yeah, I increased the value, right? But if I subtracted 4 here, these technically will cancel out, right? So but I'm doing it so I can make this thing look different. I want to make this look different, right? Into vertex form, but I don't want to change the value. So even though I'm adding 4 here, I'm actually subtracting it. It's as if I'm adding a really fancy 0 to this, okay? But this will help me rewrite this in a different way to where we can see the vertex, all right? So we're done here. The next step I will write on a new piece of paper. It will be, okay, so I'm going to rewrite that last step. It's still step 2, so don't rewrite it again. I'm just rewriting it so we can kind of see where we left off. It's y is equal to x squared plus 4x plus 4. That was a space, okay? And then on the outside was plus 6 minus 4, okay? And if you need to write on the side of your step 2, say that this was completing the square. So you remember that this was completing the square. This was called completing the square. This now reduces down to a binomial, or x plus, and what you're going to do is you're going to take, this is technically your b divided by 2. So you take the b divided by 2 value, and then you put it into this form. It's always x plus b divided by 2, and then you square it. And then you just leave, you simplify what's on the outside. What's 6 minus 4 at this point? Yeah, it's just 2, right? And then it was y equals, and this is step 3, okay? So this reduces down to this, okay? Because it's a perfect square trinomial. When you complete the square, you always make a perfect square trinomial. You always make a perfect square trinomial. So that's kind of the beauty in completing the square. You're able to reduce it down to a perfect square trinomial, okay? Is this written in vertex form? Is this vertex form? Compare this to your notes to what you just had. I made you write this. Sorry, it's a little crooked. Like they say, teaching is all in the details, and that's my one weakness, is the details. Yeah, Truman?
Isn't it supposed to be a number on the left of the parentheses? This is a times.
Oh, hey, very observant. I like that. Hold on. Let's take a look here. Yeah, let's look at vertex form and compare it to my guy. It looks like there's no a, right?
Oh, but is it just 1?
Yeah, I was gonna say, because if there's no a, technically, what would a be then? No, I'm sorry. This looks like it has no a, but it does, right? But let's say what you just said. Let's repeat what you just said. there isn't an A. If there is not an A, what would the value be for A? If there is no A? 0, right? But if we had a 0 here, what would happen to all of this? It wouldn't be there. It wouldn't exist, but it does exist. So what does that tell you about A?
It's 1.
It has to be 1. So your A, so let's break this down. You don't have to do this part in your homework, but let's just say your A is 1, okay? What is your H? What's my H? This is the trickiest part, I think. What's your H going to be? Yes. How'd you know it's -2 and not +2? Yeah, the actual form is x minus h. So this is x minus h, but if you rewrite it like in the standard form, what would we have to do to the 2 here to make this back into standard form? To the 2. What would we have to do to this +2 if we wanted to rewrite this in the real the real vertex form, x minus h, the general form? Sorry, it's kind of hard of a question to answer the way I asked. Okay, that's what I wanted to hear. Yeah, so thank you for answering. It's not an easy question to answer. So really, if we had to rewrite it in standard vertex form, what you're actually doing is you're subtracting -2. But what you finally see is x plus 2. That's a little detail. A lot of people just say this. If you're a student, though, like when I was a student, I just said this. You're saying a lot of stuff, Mr. Wee. I would just think of it like this. Whatever's in here, I'll just take the opposite sign of, okay? Like you just take the number and you put the opposite sign, okay? But now as a teacher, though, I kind of understand you have to be very technical. You like for especially students that want the more technical stuff, I want to explain that to you. Yeah, it's rewritten as x minus -2, and that's equivalent to this, okay? And your k is going to be a lot easier. What's your k going to be? Sorry. Yeah, nice. Okay, k is equal to 2. And my vertex is h comma k. So what is my vertex going to be in this equation, guys? Based on this final equation here, what is my vertex? This is step 4, by the way. This is step 4. It's what? It's -2 comma 2. Please tell me, is this your highest point or lowest point on this parabola? It is going to be my lowest point because I know it opens up because the original equation, yeah, it was a positive x squared, okay? All right. I'm going to give you an example now. I'm going to give you an example, but I'm going to kind of help you with the first step because it's a little tricky the way that they have it. Watch out. These wires are delicate. Okay. All right. Okay. So here's your example. It's B. Okay. So what we did was part A. Part B is this. And you're going to have a lot of equations like this. 2x squared minus 12x plus 17. The first step, look back in your notes. What's my first step going to be? Yeah, go back in your notes and then.
You're going to separate the x's from the constant.
Yeah, so we kind of want to separate the guys with the variables from the constant. So it's 2x squared plus 12x. But I guarantee you this will not be an easy equation unless you do one specific thing. You want to if your a is bigger than 1, okay? If your a is bigger than 1, try factoring out a common factor. What's a common factor between 2x squared and 12x? I'll give you a hint though, don't take out the x. Just give me the number. Like what's a number that we could factor out? We want to keep the x's in there, okay, to make this work. What's a number I could factor out of both 2 and 12? Any takers? Yeah. Cleanly though, can I factor out 6 out of 2? But I think yeah, go ahead. Yeah, you can take out. And then I'm going to say keep this space here. Plus 17. And you're going to subtract that space. Okay. Go on the board, okay? I suggest everybody go close so that way we could talk to each other here. I don't want you to work in isolation. Really want us to kind of like talk to each other if you're really stuck on this, okay? So please, everybody get up to the board now and then just get to work. There's a board next to Mateo. I'm going to start this over here. Thank you, sir. Here.
My favorite jacket's black. My favorite color is pretty much everything. Oh, because J code? Yeah. Wait. We can't work in isolation, so we don't get to the spot where we do.
Yeah, there's boards here too as well. And then pens are in that bucket over there. Grab whatever you guys need. And guys, erase everything else on the board so you have enough room. There's like no room on the board.
You're so good. You're a single.
Yeah. Square. Yeah. I think let's try that out. So if you take, let's see if they're equivalent. So how I do is I just take a random number. So you take like 10. So hold on. So you take 10 divided by 2, that's 5 squared. Right? Let's. You're saying to square the number first, right? And then divide in half. So let's do 10 squared is 100, right? And then you divide it by 2, that's 50. So I just did like an example. You can't do that just because it doesn't come out quickly. Hey guys, if you guys have like dry markers, throw them away. Okay? Is the temperature hot in here? You guys want me to turn on the AC? Okay. So here, Len, guys, when you add 9, right? You subtract 9. Are you actually adding 9 to this? Subtracting 9. No. You got it. No. I'm sorry. Yeah, your turn. So you got plus 9. That's fine. Okay. I'm not asking to minus negative 9. Yeah, it's true. You could just look at it like that. But be careful. Be aware that there's 2 in front. What are you actually adding to this set? Is it actually 9? It's actually 18. So when you add 18, you have to make sure that this has to compensate for the fact that you just added 18. It has to be minus 18. Okay, that's the trick here. Okay, so keep that in mind. So Allison, same here. You added 9, right? But in actuality,
Did you steal my
you didn't just add 9. You added 9 times 2. That's 18.
No.
So when you add 18, you have to make sure.
Really?
Yeah, so that's gonna be minus.
Did you really just do that?
So here, you added 9, right?
Yeah.
But now you have to kind of keep in the back of your mind that there's 2 here. So what you actually added isn't just 9.
You know what? So far, up into the history now, it's not all going to get cleared. Oh, here will take over 100 times.
Yeah, that's right. Because you got to make sure they cancel. Okay. Very good.
It will take
Great job.
forever. Good luck with that.
Cool. You're gonna love me. I'm just kidding. But okay. You see how you added 9 here? Yeah. What about this 2 out here? Did you actually just add 9? Or how much did you actually add to this? That's 18, right? So you added 18. This has to be canceled out. So this isn't just minus 9. It's minus 18. Yes. 17 that's positive 17 minus 18.
Okay, but after we get started.
No, I think. Oh, I see. Yeah, the math. That's perfect.
Can x squared minus 6x plus 9 be factored?
Oh.
Can it?
No, 17 minus 18. What's
You can do it by 3. You can do
Oh, that's right.
3 times 3
17
times
minus
1/3 x squared minus 2x plus 3.
There you go. All right, very good. That's perfect vertex form. Can you tell me the vertex now?
Alright. That is
That work or not?
2 times.
Good. That's awesome.
No, like 2 times 3.
Nice. And then your vertex is
Write
H
that out.
and K as a coordinate. So remember,
And then
vertex
parentheses. X squared over 3
that is a coordinate. Good job.
minus 2x
Good job.
plus 3.
Okay. Hold on. So,
Better know.
Yes.
Would work. If you
She
can do
went
like
and
x
some
squared
of
over
the
3.
she went crazy.
okay. So it's
It was getting perfect by
okay. So yours, you're missing one step to go from here to vertex form. You still have to. That's not vertex form. So this is a perfect square trinomial. You have to condense that back into a binomial square.
So, am I doing this really fair to multiply back out or?
No, you don't want to multiply back out, but you want to make that. So what you have now is a polynomial. You want to go
this
back.
to go back to your 3. And then x minus 3.
Yes, that's correct. So that's x minus
Or
3.
x minus 3 squared.
Yeah, that's it. That's absolutely correct. So write that out. So why don't you write it out? So, well, you have x
Minus
minus. Okay, all right. No worries.
Because I got
So you took. Oh, okay. So you didn't. You chose not to factor out the 2. Is
Yeah.
that right? Okay. All right. So not certain because if you do that, I don't know how you can make that a perfect
Look at 2
square.
times 3.
Like a
If you
perfect
multiply
square
it by 2,
trinomial,
6
you end up
times
having
x
x
squared over 3 would
plus
be 2x
something,
squared.
right? Squared, right? I don't know how you're gonna do that.
2x squared
You see what I mean?
minus 12x
I don't know how you could do that from a 2x
plus 18.
plus whatever, 12x plus something, right?
okay, so if I
No, that
So
would
the only
be
way
2
you can
times,
make
the
it
2 times
into a
3 times
perfect
x squared over
trinomial
3.
is if you
Erase
focus
that
on
6 on the
making
bottom and
the
then just
A
drop arrow or like
kind of like
equals at the top.
like not arbitrarily, what do you call that? Artificially, the A, when you factor out the 2, you make it so where the A is just 1, right? So it's just really hard to make a perfect square trinomial like this. If you have that statement there, you get 2x squared, right? But is that a perfect square right there? Or is that a perfect square?
Wait, do I have this right or are we doing a Patterson here? Did I miss that? Or did I miss a Patterson?
No, you're good. So you did. It's your B is technically negative 6, right?
Yeah, okay, right.
So it has to be So yep, you're good. Now you're absolutely good here. Okay.
Yeah.
So
See, we are not pulling a Patterson. I was wrong.
I don't know what that means.
Okay, so do you know what the show Blind Spot is? Okay, so there's a show. It's really good on NBC, and there's a hacker in the show named Linda Patterson, and she always is saying opposite. Like so.
Oh, okay.
So
So
like
that's why.
opposite,
Alright, that's a
or
pretty cool
are we
reference.
just?
That's a pretty good reference. I like that. Okay.
Because she's constantly saying that, and she got it from her dad, which in the show her dad is actually the lie. So.
goodness.
That's cool.
You gotta love TV shows.
Crafty.
All right, I'm gonna write out the steps so you guys can.
It's a show where they use tattoos to solve FBI cases.
So you take this, you square that. This would be.
It's a really good show. It's an FBI show where they solve cases based on tattoos that they got from a criminal organization.
I'm just gonna trust you. I even tried to watch this.
It's a really good show.
Okay, so you guys can write this in your notes. I'm rewriting the solution. Oh, whoops. That should be. positive 3, and then your vertex.
It's tattoo company.
So in your homework's going to look sort of like this, okay? Pretty much. This is what I basically want to see. So besides me talking and trying to go through all the concept, this is, at the end of the day, this is pretty much what your homework's going to look like, okay? So sometimes I forget. I forget when I was a student, I would take down all the notes and listen to the teacher, and then because they talk so long, you don't know what you're actually supposed to do. So I got to remember that. So I remind you guys, hey, this is after all that, this is it. This is all we just did. Okay. All right. Any questions so far? I think you guys did really well on that. Yeah?
Mr. Wee, on the homework,
Uh-huh.
when we're checking our answers on Google Classroom, 3-4 is actually the 3-5 answers, and 3-5 is actually the 3-4 answers.
That's really confusing. So did you guys hear that? I think there's like mislabeling. It's from the publisher.
Yeah, there's mislabeling on it.
So when you guys,
Yeah.
Cover sheet mislabeled?
is it?
Well, I looked at it in the first one. It says 3-1, but 3-1 doesn't really exist.
Does it? Shoot. Let's take a quick look really quick. Just letting you know if this takes. Oh, no way. All right, let's see. All right, Mr. Wee site. Math. Come on.
Yes, it's on the Google Classroom now.
Go. Oh, really?
It's on
That's what you're saying? Or on the cover sheet or the Google Classroom? Okay, so hold on. So she's saying the cover sheet. So let's take a look at the cover sheet here.
Nice. No, it doesn't.
Okay, I'm gonna put it up, and then Malia, describe to me what's going on here. So maybe I can kind of fix it. I don't know. It seems like you guys aren't flinching, so I don't know if that means that you guys are just like you notice that too. But okay, so where is it that it went wrong? Mm-hmm.
It doesn't really exist in the book besides just a calculator.
So 3-1. Okay.
Oh no, I think you're looking at the lab portion or whatever, like these example things that they stuck in there.
Okay. Okay, I'm gonna put this up under the DocuCam. All right. You.
Oh my god.
Uh-oh. Have you been doing the?
Yeah.
Okay, so don't worry. Don't do anything differently from like how far are you right now in the homework? Okay.
If you flip back a page, I think is maybe like
Let me see. Yeah.
behind
You could
before.
hold on. It might be that her book too might just not have the 3-1 too, you know? Because it's just the publisher sometimes like they literally miss chapters. Like I don't know how you do
Yeah,
that, but
what she was saying was it was a calculator activity, so it could be that what either from in front or behind when they have the extra.
like this one right here.
Yeah.
This is the page right before. Do you only see this part, Malia? Actually, yeah. Let me give you a second to look at.
That's all I see.
And then you flip the page. There's no 3-1.
It just goes to 3-1.
Okay, so it sounds like it's just her book. So okay. Does anybody else have their book on them? Leonard. Hey, do you have a class afterwards? Do you have a class afterwards, Malia, or do you have somewhere to be? Okay, shoot. How about this? I'm gonna ask you guys if you guys can you guys exchange phone numbers, and can you send Malia the page numbers or the pages? Okay, like
Oh no,
screen.
I can't. My phone number's broken.
Okay,
I can do it later.
Catriella, can you do that? Can you guys exchange numbers?
The day you text me to the library.
Yeah, I have my book at home.
I know, but it'd just be easier if, like, you know, Malia doesn't have to go to the library and then take pictures and stuff like that, you know, because it seems like you guys are all busy, so you guys can just do this at home. Okay, And then for you, if you finished like 2 or 3 sections already, okay, like don't go back and redo. Just keep how you've been doing it, but go back and redo 3-1. Okay. So Malia, just go back and do these problems for 3-1. Okay. Okay. So, all right, we're gonna move on. All right, I gotta move on. Okay, is there anything else we need to cover before I jump back into the content? All right. Okay. Next one's a doozy. Everybody please write this down. 3-5, quadratic inequalities. Quadratic inequalities. And we're going to learn how to graph something that looks like this. Graphing an inequality, okay? Graphing an inequality, and you're going to graph something that looks like this. Here's an example. I would like you to graph this x squared plus 2x plus 4, right? I would like you to, but that doesn't mean you know how to. So do me a favor. This is going to be your next whiteboard problem. I want you to graph just y is equal to, like normal. Graph this, okay? On your graph, I want you to have the coordinates for your vertex and maybe 2 other points, okay? I want you to find a space on the whiteboard and graph this for me. You can do it however you want. You can do it through the calculator. Truman's got his calculator, so it looks like you're more comfortable using the calculator. You guys could do it with a T-table, okay, and do it by hand. You guys could do it however you want, but I want you to graph this somewhere on the whiteboard, okay? If you don't know how to, ask other people for how they would graph this, okay? How are you guys doing the homework, okay? You can ask each other, oh my gosh, I like that way. That would save me a lot more time if I graphed this. Oh, you've been doing it the longer way? I have a fast way. Or I don't like that. I'm just going to stick to it my way, okay? Whatever it is, graph it. I want to see how you guys are graphing it on your homework. Just y is equal to. Don't worry about y is less than. Just y is equal to.
I thought they were all shifted over one on my cover sheet because my whole book is like shifted over. So 3-6 is correct.
Oh my gosh. So, that's not good. Okay, so
like all of them are shifted over.
So 3-1 is actually 3-2. So you haven't been okay. So you're still on pace, pretty much, right? So you don't have to redo anything, and you're not lacking any chapters. It's just here's
Except 3-1 because that doesn't exist.
Do you have do you have a theory for why they did this? Like, what's your theory? Okay, my theory is this is a newer book or an older book, and then they screwed up on the printing. Someone went back and refinished everything. Like, okay, oh my God, guys, 3-6 should be 3-5. We don't have a 3-1. So, I mean, all these are created with like Word, like Microsoft Word, so you can imagine someone going doing backspace. So from now on, you're the one person that's got to shift everything over to. Right. But as long as you're on pace, you're perfectly fine. Okay. Let me know if there's any other discrepancies with your book, and I think I might have to take a note of your book so whoever gets this next year. Because we were lucky that you found that out, but I don't know if the next person using it will see that right away.
Oh, that's why you return it to them. You tell them what's wrong with it. They give you a new book, and they take that one and scrap it.
All right, Malia, do you want to do that? Okay, so see if the office has any more.
Yeah.
I'm not sure if they do though.
Last year, my book had profanity written permanently with pen and ink in it, and they took the book and they put it through a shredder.
Got it. Okay, that's good.
Yeah, I showed it to Mr. Greenwood, and he said, "Yeah, they'll shred the book. They send it back to some place, and they get the books."
Well, hopefully they don't shred this one because it's still useful.
Yeah,
But
it was
something's got to be finished.
No, I wouldn't. I'm not a teenage boy. I don't do ridiculousness.
You're gonna put out 145.
Closing online for
You do the same thing. I'm not the one who did it. She did. She said you didn't realize you're talking to a boy.
Okay, from now on, you will see what I'm doing.
I didn't say anything about you or anything like that. I said boys in general. Generally
somebody would do it.
Oh, yeah, are you having trouble figuring like words?
Let's see. What we can correct you later if you're incorrect.
Here's the old way of doing it. You can do just export tables. And then you just pick some random points like if you're gonna makes your OC. And just plug it into the equation.
Yeah, you
X
really
squared
know
plus
how to hit them.
2x plus 4. Okay. So that's one way. Another way is actually your calculator.
Yes.
so that we can hit that.
Yeah.
It gives you the-
And then yeah, put it in there and then x squared plus 2x plus 4.
I just don't associate math and fun with you.
Oh no, I would think so.
Still the points of the
I like how mine is bigger, but I have a smaller graph.
Let me see this.
Where do you have
Where do you have this point right here, right? Okay, so
And then let's draw an axis right here.
go down. Okay, so this is your negative 1. Three next.
Well,
Well, not negative 3, sorry. So negative 1 and then 3.
And
You're right here.
okay, so you graph it. Press second
We should get another one.
I don't know what I do.
table, and then you can put your values. So that's one way.
On 0
And I would say just pick at least 3 points that are kind of far apart.
I'm not judging you for anything. You said, like, I thought you were saying.
Yeah, just draw it on this axis.
You figure out. Yeah, but purple.
Yeah, it's gonna go on the same value.
So you guys figure out a way that works for you, and I'm going to show you how the book does it. Okay? How did you boys do it?
The table.
So you guys did the table. Okay, so a lot of people like doing the table.
Hello, Panda. Hello. How are you? Because I like your haircut.
Great, right, cool. The vertex right there. Very good. And then you said label 2 points, or yeah, like label me like yeah, at least 3 points. 3. So guys, on your graph, label at least 3 coordinate points that are on your graph. You can use your calculator. You can do whatever you want. Okay.
Sometimes I feel like.
You can use the t-table, but really on your graph, I just want 3 coordinates. Right?
But if you think about it, we act like.
That's good, right? Just like that. So Len and Truman, I like theirs because they have 3 points literally they on the graph. Okay. I'll give you guys about 5 more minutes to finish up your graph. And then I'm going to show you how they did it. I'm going to tell you where this less than or equal to is going to be, how it's going to be in play. Okay. I'm gonna turn the AC. Sorry guys, I got an amazingly high body temperature. It's almost hot. Internal heat. Anybody have plans this weekend? No.
Hanging out with this one. If
Nice.
her parents will let her.
Okay. All right. Fair enough.
And my birthday party.
Yeah, happy
with my
birthday.
family.
How old are you now?
I'm gonna be 15.
Nice.
November 17th. So
Okay.
my family's doing it a little bit early because my uncle can't do it after that.
All right. So you're trying to be inclusive of your uncle, yeah?
Yeah.
That's really cool. I like that.
Nice.
All right, guys. So here's the deal, too. Keep this in the back of your head. Today, I'm going to get through 3-5. All right. I'm not going to get to finish it in class. Okay. So I will post a video on 3-5 where there's another section in 3-5. Then I'm going to post a video on 4-1. Okay. That's how to draw exponents or exponential graphs. Okay. And then next week, we're going to immediately start on 4-3. I guess that means that in my cover sheet, hopefully I skipped 4-2 or no. Or maybe I thought it was easy and I didn't need to go over it in class. Let me take a look at what this means. So Mr. Lee's cover sheet or integrated math 2-1-3.
Yeah.
Okay, so I do apologize. So that means, oh, wow. Okay, so here's the deal. Again, I'm going to repeat this one more time. We went through 3-4, the stuff I wanted you to know, okay, at least for the exam. Then, right now, we're doing 3-5, but we're not going to cover everything. So there's going to be a part 2 video on this. Then I'm not going to go over this in class at all. But there's going to be a video for 4-1. Next week, when we return, we're immediately going to start on 4-3 and then 4-4. We will not touch 4-2. So I believe that tells me that 4-2, I'm hoping that it's easy to learn on your own, okay? If you have any problems, though, you need to see me during tutoring, at least next week, before I get bombarded in the 4th week of the test, okay? That's when everybody comes in, first come, first serve. It's really hard to get your question in. So I can answer. Yeah, Len.
Will there be a study guide for the test at all?
No, there's no study guide normally in my class. I'm sorry. That's where I guess me and Mr. Green would differ. But the best I could say is this. You go through my class notes for your exam. That's how you study for your exam. You go through all the videos and whatever we go through in class. Everything I talk about is on the exam. Then you look at any problems like that and you practice it. That's pretty much it. Okay, that's pretty much it. Normally, I would maybe pick one other random problem, but it's not too out of the depth of what we go over in class. I think that's the essentials of what you need to know and what you should be tested on. Okay. The rest of the book, though, will make you a stronger mathematician, even if you don't like it and you don't think you're doing anything better. There is a difference between someone that has never been doing the problems and a person that has. I know this is a little bit of a digression, but like when I went to Vietnam, let's say, I didn't think that learning stuff that I had no bearing and no care for in school helped me at all. But there is a difference between those that are uneducated and didn't get a chance at education, even if they wouldn't care for the classes, and someone in this country that takes classes. And even let's say they don't even pass the classes. Okay. The fact that they're exposed to some kind of education and their brain has to like kind of trigger at some points, there is a big difference between the two individuals. Okay. So that's kind of where I want you guys to go. I'm not asking you guys to remember this till the day you die, but I am asking you guys to try your best because your brain fires off and does grow from it. It's not a metaphor. It's scientifically proven. Your brain, the neurons and so forth, okay, they do strengthen, okay, and you do become an individual that can critically think. That's our goal. Okay. Again, I went way too off the rails just now for that. Okay, so anyways, let's go back to just math, right? So here's how the book does it. You guys graphed it with a graphing calculator, right? Okay. Allison, I like yours, Allison, but what is incomplete about your parabola, do you think? To make a proper parabola, what do we need to add to your graph to make it a proper parabola? You have 3 good points, right? But do parabolas stop?
Oh, no, they don't.
Okay. No, it's okay. It's okay. I'm not asking you to get up and do it, but just keep in mind, okay? So, because I'm just going to say what you did, a lot of people do, okay? So just make sure you draw the arrows, right? Okay. No, just so you know. Just an FYI, I guess, okay? Okay, so in your book, here's what they do. You got to learn. You also should know how to do it by hand. You guys already know how to do it with a calculator. But in the book, it's going to present it like this.
Oh, the one with the red was.
Oh, I'm so sorry. Whose was the blue one then? All right. Well, I would just say it's still good. It just needs the arrows. Okay.
Oh, I gave up.
Okay. Fair enough. Okay. Yeah. That's not to say, oh, you did, like, what's up with you? Okay. It's more like, okay, just keep in mind that parabolas always go on forever. Might be trivial to you because you might already know. Okay. So the vertex, you have two choices. Either you can make this into vertex form, which I don't know if you guys are comfortable doing on the spot. So the way that most people remember how to do that is they do negative b over 2a. They bite the bullet and they just memorize that. Then they plug in. So write this down as your notes at least, okay? You guys learn how to do it through the calculator. But let's see how close your vertex was to the actual vertex calculated through math. That's negative 2 because my b is 2. My a is technically like an invisible 1 that goes in the front. And then my c is 4. Negative 2 divided by 2 times a, which is 1. That's negative 2 divided by 2. It's negative 1. Is that my vertex, though? Is that the answer for my vertex? No, because vertexes are what? Are they just singular x equals 2 things? No. What's up? It needs a y value because it's a point on the graph, right? So we have this. How do we know what the y value for this x point is? Yeah, you just take the original equation and then you plug it back in. So great. Awesome. You just put negative 1 and you're going to square that plus 2 times x, which is negative 1. That's the point that we want. And then you add 4. That should be 1 plus negative 2 technically plus 4. I'm sorry, I'm not going to show every single step, but in your head, hopefully you guys calculated 3. Is that what you guys got? Yeah? Okay. And then my actual vertex is negative 1 comma 3. That's a point, okay? Lowest point or highest point? Ah, very good. Okay. So, and in the book, they want 2 other points. So you guys looked at it on the table, right? But I at least want somewhere in your notes that you know how to do this. So someone pick an easy x value to use. A random x value. 4. All right. X equals 4. Then you're going to plug it into the y equation. So that's 4 squared plus 2 times 4 plus 4. That's going to be equal to 16 plus 8 plus 4. And I think that's 28. So that's 4 comma 28. Okay? That's a point on the parabola, right? Got it? Yeah. Someone else pick a very easy x value.
2.
Okay? Okay, so we're going to do y is equal to, let's plug this in to 2 squared. Do this on your own if you can, and then look up here to see if you get the right answer as I did. 2 squared is 4 plus 4 plus 4. I got 12. So another point on the graph is 2, 12. And then in the future, I would suggest this. If your vertex does not have a 0 in the x value, I would really suggest 2 other points. Plug in 0, right? That's really easy because that's just 0 squared plus 2 times 0 plus. It's really nice, okay? So just a suggestion. Now you're going to graph this. Yikes. Okay, so I'm going to put in little increments like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Sorry, guys. All right, that's because we picked 4.
Could have done it by 2s though, to made everyone count for 2.
Okay,
And that would
you got a point.
have,
All right.
even by 4.
Or even by 4 if you want. Okay, you could have made the increments, but I like to go super basic and just go by ones. They're easy for me, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3. I don't know, guys. Just make a ton of them. Try to equally space them, okay? I know at 4, I have a 428. So 428, 2 comma 12. Oh man, I don't even know what that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, guys. Please don't think I'm doing this perfect. I'm just trying my best here in the interest of time. And the other one is -1, 3. I guess that's down here. And then I'll just complete the rest of my parabola, okay? It's not perfect, but hey, it looks good, okay? What time is it? Shoot. Okay, I got 4 minutes. Okay. Here's the kicker, right? Here's the kicker. This this is every point on this line, okay? You guys get it? Every point on this line follows this. Y is equal to x squared. What's the equation? Miss Gold, can you tell me the equation? Y is equal to x squared what?
X squared plus 2x plus 4.
Okay. Every point on here is, if I plugged in the x, I would get out this y, is equal, right? Am I asking you to graph that? What am I actually asking you to graph? No. Look at the original equation here. What am I asking you to graph? Am I asking you to graph y is equal to x squared plus 2x plus 4? What am I asking you to graph? What is different between y, this equation and this equation? What is one key? Yeah, Len.
Asking us to graph the points that represent that equation.
And this equation is not the same. It's less than or equal to. So what I'm asking you is not for the points on this graph, but all the points that make this statement true. All the points on this guy, if I plugged it in, it would be... Catriella, guys, please. Okay. All the points on this graph will make this statement true. Its y coordinate will be equal to, if I plugged in the x coordinate, right? But again, I'm not asking for that. I'm asking for every single point that is, if I plugged it in, I plugged in the coordinate, and I plugged in the x, and I plugged in the y, this side would always be greater than whatever my y value is here. So I'm going to say this. What this means is that could be every point below the parabola or every point above the parabola, okay? How you do that is you test 2 points. So you test 2 points, meaning this. I'm going to pick a point that's definitely not on the parabola, but below it. What would be a coordinate that is below this parabola? Yeah, 0, 0 technically is. So let's just test out 0, 0. And let's plug this in. Y is equal, we don't know what y is. Y is equal to, what is it, x squared plus 2x plus 4. Let's plug in 0 and 0. 0 is equal to 0 squared plus 2 times 0 plus 4.
Basically, the actual inequality is less than or equal to, so it would be true.
Yeah. So we're trying to test this inequality. I'm sorry. So yes, you're absolutely right. This is a big question mark. Will this come out true? Guys, is this point, when I plug this in, will it give me a true statement? Is 4 greater than or equal to 0? Yes. If that is true, that is the side you shade. What this means is every point, including the points on this parabola, will make this statement true. X squared plus 2x plus 4 is greater than or equal to y. Yes.
So do you like formally write it by shading?
Yes. Just to check though, try a point that is above the parabola, that you know for sure is above the parabola. Try one out. Give me a point that is not on the line, that you can guarantee it's not on the line. My suggestion is to go from the vertex and then move up. Any other point at this point, you don't know if it's actually on the parabola. So give me a coordinate that is above, like either slightly above or way above the vertex. -1, 5? And what'd you say? -1, 4? Huh? 1 and 4? Are you sure that 1 and 4 are not on the parabola?
Oh, no, wait.
See, that's what I'm saying. The easiest way to do this is Look at the vertex and go straight up. I like that point is -1 and 5 because that can't be the parabola just keeps going on. It doesn't go straight up, right? It never goes straight up. So wherever the vertex is, I would go straight up, and I know for a fact that's not going to touch the parabola. So let's check that out. 5, will 5 be greater or less than or equal to -1 squared plus 2 times -1 plus 4? That's really hard to see. I'm sorry. That's going to be 1 minus 2 plus 4. And 1 minus 2 in my head is -1 plus 4. I got 3. Is that true? That is false. If that is false, should that be the side I shade? Okay, very, very good. Okay? So you're not graphing the parabola. You're graphing all the points not like off the parabola as well, either below or above. One more thing. What if I changed it? I have one more thing that I got to add before you guys leave. I'm sorry, I'm keeping you guys a little bit over. What if it was just less than and I didn't have the equal sign? What do you guys think? What if it was just less than and not equal to? What are the... Oh, go ahead, Catriella.
If it's on the line, then it wouldn't be part of it.
Yeah.
Indicates that.
The line indicates...
So when it's equal to, then where like on the parabolic line is still a part of that, but it's not if it's not equal to.
Okay.
Don't you do a dotted line?
Yes. Okay, so here is the kicker, all right? If it is less than but you don't have the equal to sign, okay? If you don't have the equal to sign, remember the parabola represents y is equal to x squared plus 2x plus 4, okay? If it is just equal to, or if it's just less than or greater than, what the parabola is, it becomes like a fence, and then you dash the line. You don't make a solid line. What you're saying is, hey, I know where the parabola is, but technically if you're going to ask me for all the points that are less than, like that make it less than, then it's only the shading. It's only the part that's shaded, and this should be dotted, okay? All right, I'm going to probably do an example on a video for you guys for that one, okay? You guys, that's it. That's all there is to it for this. You guys go home and take care. Put away the seats, please, and I will see you next week. Please watch the videos, okay? Thank you, guys.